object in the real world. For example, this is the examples for the objects and class. This is the examples for the objects and classes. It means in the left there are 3 different bicycles, and each one is a concrete object in the real world. For example, this is Tom's bicycle, this is Jack's, and this is someone else bicycle. And it means in the real world there are many different bicycles or different objects. And if we want to develop a software system to manage so many objects, we need to abstract these bicycle objects into a bicycle class. And in this bicycle class, we need to find some important attributes to the system we want to develop. For example, for the bicycle attributes, it means the frame size, wheel size, number of gears and materials, and some operations. It means we can shift, move, or repair this bicycle. And for example, for another, we want to develop a software to implement the editoring of some graphics, or for example, for some software, we can draw the different kind of polygon objects. For example, we can draw a rectangle, we can draw a triangle, and there are different polygon objects. But if we want to manage them in a software, we need to abstract them into a polygon class, and we find 3 important attributes to this software for the polygon class. It means the verticals. It means for each polygon we have 3 or 4 vertices, and the border color, what is the border color, and what is the fill color, and so on. All of these attributes are very important to draw each polygon, and there are also some operations important to our important to the software we want to develop. It is a draw, erase, and move. It means in this software we can draw this polygon. For example, after we draw this polygon and we store it into a file system, and next time after we load the file, we need to draw the picture, or we need to draw the polygon again. And we also need to erase the polygon, or move the polygon from one position to another one. It means this kind of software need to implement this kind of 3 different functions. It means this is operations very important to this software. But sometimes for the same groups of objects, if the software is different, the class may be different. It means that objects are sometimes real world objects, or some conceptual, or some objects in the computer system. And although they have many different objects attributes, but the attributes important to the software depends on what kind of software you want to develop. It means we need to choose appropriate attributes for the classes in a specific software. And inheritance is another characteristic of object orientation. So inheritance is it means is a sharing of attributes and operations among classes based on a hierarchical relationship. It means that just now we have mentioned that we have abstract different objects into classes, but sometimes for the system, for a software, we need to manage the objects maybe belonging to different classes, but there are some hierarchical relationships between these classes. For example, if we want to develop a software to manage the computers or laptops and some mobile phones or cell phones and some servers, it means that actually they belong to several different classes, but this kind of classes has some hierarchical relationships. For example, the computer, the laptop, and the desktop computer, sometimes they share some common attributes and some common features. But could we use some techniques to sharing these attributes and sharing these operations? It means that in the hierarchical, there are some superclass and some subclasses, and in the superclass, it means that it has the common attributes and the operations belonging to all of these classes. But some subclasses refine and elaborate the attributes. For example, so in the next slide we will see an example of this. For example, for a computer, it is a desk computer and laptop, and the computer is a superclass, and it has some important attributes. For example, screen size, CPU speed, memory size, number of process cores, and has the function, also has the operations start and terminate. This is the desk computer is a subclass of the computer. It means that the desk computer shares all of the attributes in the superclass, and the desk computer has some its own attributes. For example, separate display and some CD-ROM. But for the laptop, it has its own unique attributes. For example, the Wi-Fi. And the laptop also shares the common operations. For example, the laptop can start and can terminate. It means that these three classes, it means in this system we have different kind of desk computer, different kind of laptop, but all of them belonging to the superclass computer. And we have found some common attributes for the superclass and some unique attributes for the subclasses, and through the sharing of this information we have decreased the work, or we have simplified the system design, and so the ability to factor out common features of several classes into a superclass can greatly reduce repetition within designing and programs. It means when we find there are different kind of computers in the system, we need to factor out some common attributes and common operations and construct a superclass for these different objects or different classes. It means in the system there are many different classes, and if we could factor out some common attributes and common method, we can construct a superclass. And sometimes the hierarchical, the layer may be more than 2. It means for the laptop there may be different subclasses for the laptop. For example, for the for different band and so on. Okay, polymorphism. We can see that in this diagram, for the superclass and subclass, all of them share the same start and terminate. But sometimes, for example, for the different kind of polygon, they all share the same operation draw. It means we need to draw the polygon, draw the rectangle, and draw the triangle, and actually the details of the methods to draw different polygons is different. So we cannot use the same implementation to the same code to implement the same operations. So it means the same operation may behave differently for different subclasses. And it means we need to implement, for example, we need to implement the operations for each subclasses separately, and the implementation of an operation by a specific subclass is called a method. It means that although these different subclasses they share the same, or they have the same superclass, and they have the same operation name, for example the draw, but for the same operation there may be different implementation, sometimes each for a different subclasses. Like this is a polygon, and in the system we need to manage the two kind of polygons. One is a rectangle, another is triangle.